So we will be solving 3x3 systems, and what I'm doing right now, my goal is to get you comfortable using these steps right here to solve this 3x3 system, okay? Now, let's read through it and apply each of these steps to this 3x3 system. Again, last week we were doing 2x2s. We had 2 equations with 2 variables. Now we actually have 1, 2, 3 equations with 1, 2, 3 variables. These are called 3x3s. Anyway, step 1, use 2 of the 3 original equations and modify them to get a variable to cancel. So let's look at this. Now, we need a variable to cancel, either the x's, the y's, or the z's, right? So what do you think's easier to cancel? The z's, the y's, or the x's? Okay, now, and there's, the beauty of this section is that there's so many roads to the same place. You could decide to cancel out x's, while somebody else maybe decides to cancel out z's, or maybe somebody else cancel out y's, right? Again, the first step reads, select 2 equations and get a variable to cancel. I am going to pick well, first of all, what do you guys want me to cancel? X, y's, or z's? Okay, I'm going to go with z's, all right? Z's. So if I want z's to cancel, which 2 equations would I use? The first one and the third one? Or the second one and the first one? Or the second one and the third one? It's up to you. First and second. Okay, so if I want z's to cancel on the first one and the second one, I need to change this to become what?
2.
Bless you. That's right, a 2. Okay, so we are going to put parentheses around the second one. And we're going to put a 2 out here. And it's very important that we're very clean with our work. Put the parentheses, put the 2, draw a little arrow. As a matter of fact, I want to first start by rewriting my top one, all right? Even before distributing on the second one. Rewriting the top one, I'm going to write it up here. It's going to say 3x plus y minus 2z equals 10. And yeah, you're going to have to write pretty small, right? Unless you rewrite this in your notebook. Then you'll have more space to write. But that bottom, or that middle equation, we said we're going to modify it by 2, by multiplying by 2, and we'll get 12x, and we'll get minus 4y, and we will get plus 2z, equaling negative 4. Are you with me so far? Okay, and now the whole purpose of picking the 2 and modifying the second one was because you guys told me to cancel out the z's. So let's do that. Let's combine the lines. Those z's really do cancel out. What do we have left? We have 3 plus 12, that's 15. Of course, we're talking about x's. A positive 1 with a negative 4, that's negative 3, and we're talking about y's. Negative 3, talking about y's. And last but not least, 10 take away 4 is 6. Got to be very careful with all this work. Now, this, ladies and gentlemen, is what I like to box it in. I want you to box it in. I want you to label this new equation number 1. New equation number 1, okay? And that is barely step 1. Okay, let me go back and reiterate what we did. Let's read this step, and let's go back and show what we did. And if you have a highlighter, you might want to use a highlighter right now. It says, number 1, use 2 of the 3 original equations. We decided to go with the first one and the second one. Okay, we went with those 2. It does say modify it to get a variable to cancel. So what variable did we cancel? The z's. Now you could have chose to cancel out x's. You could have chose canceling out y's, whatever you want, right? There's like 1,000 different ways of solving this problem. But yeah, we got the z's to cancel, and we ended up producing a new equation that only has 2 variables. We call it new equation number 1. So I want to highlight this also. That's the goal of step 1, to create this new blue equation that only has 2 variables, x's and y's. Okay. Now it doesn't have to be x's and y's. It could be x's and z's. It could be y's and z's. But in this case, since we decided to cancel out z's, we have this new equation that says x's and y's only. Let's move on to step 2. Step 2 says, go back to the original, use the one you have not used. And you know what? I want to highlight this in red. Use the one you have not used. Which one have we not used? We haven't used this third one yet. So I definitely need to use that third one. And here's the important part of step 2. It says, get the same variable to cancel. Which variable did we cancel on step 1? Z's. So I need the Z's also to cancel on this step 2. So I'm going back, and I'm going to use this one that I have not used, but I need this Z to cancel. Very important that we cancel the same variable that we canceled up here on the first step. We need this 3Z to disappear. How am I going to make this positive 3Z disappear? Am I going to use the first one or the second one? Which one do you think is easier? Second one, for sure. And how am I going to use the second one to cancel with this 3Z? Times it by negative 3, right? Okay, so let's do this. This is the one we haven't used. I'm just going to rewrite it right here. It's a x plus, and write really small, by the way, and clean, plus 3Z equals 7, okay? And now I'm going to use the second one, and I'm going to modify it. I'm going to put a squiggly underline underneath the second one, and I'm going to draw an arrow, and on this arrow going this way, I'm going to actually write out some notes to myself. I'm going to say multiply by negative 3. Now, why would I say multiply by negative 3? Because that's how I'm going to get the 3Z to cancel, okay? So when I say 6x times negative 3, what will I get? Negative 18. And of course, we're talking about x's. When I say negative 2y times negative 3, what will I get? Positive 6, and we're talking about y's. When I say positive 1z times negative 3, negative 3z. When I say negative 2 multiplied by negative 3, what do I get? Positive 6. Are you with me? Okay. So again, the whole purpose of modifying that second one was to get the same variable z to cancel. So let's actually do that. Let's combine these lines. And we have x minus 18x. That's going to give us a negative 17x. The 4 plus 6, right here, 4 plus 6, that's going to give us 10. We're talking about y's. And yes, right here, the 3z and the negative 3z cancel out. And we end up with equals 7 plus 6. That is 13. Everybody with me so far? Yeah. Okay, and like I said, there's 1,000 different ways of doing this. Maybe you didn't pick the first and the second one to start with. Maybe you picked the second and the third. Maybe you didn't cancel out z's. Maybe you cancel out x's. So there's like 1,000 different ways of doing it. There's like 1,000 different roads to the same place, right? But anyway, this is step 2. We have created a new equation, number 2. Box it in, label it NE number 2, okay? Let's go back to our steps. Again, the purpose of this video is to help you get comfortable with the steps. Once you're able to use the steps good enough, then you won't need the steps anymore. It's kind of like riding a bike. Once you understand it, you'll be able to do it without thinking of it much. All right, so once again, step 1, use 2 of the 3. Those are the 2 yellow ones. And we decided to cancel out z's. We modified one of them, and we got this new equation number 1. That was step 1. Step 2, go back, use the one you haven't used. That's this red one. I rewrote it. And then I modified the middle one to get the same variable to cancel, creating a new equation number 2. Now we're on to step 3. What does that say? It says create a new 2x2 system. So all we're going to do is take this equation and put them right on top of each other to create a new 2x2 system. Now we should be pros by now at solving a two equation system that has only 2 variables in it. So once again, step 3, rewrite your 2 new equations, creating your new 2x2 system, okay? So what is my new 2x2 system? I have a 15x minus 3y equals 6, and then I have negative 17x plus 10y equals 13. Do we all see that all I did was take this new equation and this new equation, and I just rewrote them, right? And now we have a 2x2 system that we had last week that we could solve using linear combinations, right? And that is step 3. Create your new 2x2 system. Here it is. Now solve it, okay? So I'm going to ignore everything that I've done so far. I'm just going to focus in on this new 2x2 system, and I'm going to solve it. How would we solve this last week? You want either x's or y's to cancel. What do you think is easier to cancel? The 15 and the 17 or the 3 and the 10? Obviously 3 and 10, so you want the y's to cancel. So how could I change this to cancel with this? What do I need up here and what do I need down here? I need I need times 10 to give me a negative 30, and down here I need a times 3 to give me a positive 30, right? So that's what we're doing. Let's modify both equations. On the top, multiply it by 10. On the bottom, multiply it by 3. Again, very important that you show all your work. Be very careful when you're doing this. Draw arrows to your new equations. Up on top, 10 times 15 is 150. Dang, huge number. I'm getting scared. And of course, we're talking about x's. And then 10 times negative 3, that's negative 30. We're talking about y's. Equals 10 times 6, that is equals 60. Right? And now on the bottom, we have 3 times negative 17. Dang, that's ugly. What's that? That's negative 51? Yeah. Negative 51. Talking about x's. And 3 times 10 is 30. That's pretty easy. 30 y's. And then 3 times 13, that's 39. And like I said, these numbers are starting to scare me, but let's just keep moving forward. Combine those lines. When I do 150, take away 51, that will give me a nasty 99x. These guys over here do cancel. I have an equal sign, and thank goodness 60 plus 39 is also 99. So what happens here? What's my answer? X equals 1. Thank you so much. X equals 1. Now, we are solving a 2x2 at the moment. Remember, we created a new 2x2. Here's our new 2x2. We have one answer. I need the other. What do? You just plug it in. You substitute. That's right. So do you want to use the top one or the bottom? It doesn't even matter. Top. Okay, so let me rewrite the top. The top says 15x minus 3y equals 6. I rewrote the top one right here, but I put parentheses instead of x because I know that x equals 1. So I'm going to take that x value of 1 and put it right in there. And now I could solve for y. 15 times 1 is 15. 15 minus 3y equals 6. So I need to get y by itself. We're going to subtract 15. Subtract 15. We will end up with negative 3y equaling, what is that? Negative 9? Yeah. Final step would be to divide by negative 3. Divide by negative 3, giving me what? Y equals 3. So we have found the answer to the new 2x2 system that we created, right? And that was, check it out, let's go back up to the steps. That was creating our new 2x2 system. Create new 2x2 system. We did that right here. Here's our new 2x2 system. And we did all that work. We have our answers. So now we're on to step 4. Substitute your answers back into any original system. Okay? So we're going to take these two answers of x's and y's, go back to any original, and plug it into x and y. Now, you're probably thinking, well, which one do I plug it in? We've already used all three of them, so it doesn't matter which one you pick. I don't know. Which one do you want to do? Top, middle, or bottom? Bottom. Okay, and it doesn't matter which one. So yeah, let's do the bottom just because he told me to. And I need to rewrite that bottom one. And this is what I want to do since I have this pretty awesome tool right here. I want to cut it, and I'm just going to drag it over here to where my other answers are at. Okay. And I'm going to plug it in. I want to plug in those answers, the x value and the y value. So check it out. I'm going to rewrite it. X plus 4y plus 3z. We don't know what z is, so I'm not going to put parentheses on z, equals 7. So we know that the x value is 1. We put that in. We know that the y value is 3. Put that in. And now we're going to do some math. What we have here is 1 plus 12 plus 3z equals 7. Of course, 1 plus 12 is 13, so I'm just going to rewrite it. 13 plus 3z equals 7. Let's continue to solve for that third letter z. Let's get that 13 on the other side. Subtracting 13, subtracting 13. We end up with 3z equaling negative 6. Final step, divide by 3, divide by 3. Z equals negative 2. Ladies and gentlemen, we have our three answers. We have our answer x equals 1, y equals 3, and z equals negative 2. So on the assessment Friday, where you have to type in your answer, we're going to type it in exactly like that. You're going to open up some parentheses, ordered pair, actually there's an ordered triple, alphabetical order, right? X, Y, Z, first one X, second one Y, third one Z. So there is your answer. That's how you're going to type it in. Open up some parentheses. You can put the 1, comma, 3, comma, negative 2, close parenthesis, no spaces between your term. Hit enter, and you should, you'll have an answer at least. But how could we double check and make sure that this is right? Plug it in. Now, it's not just about plugging it into one equation. It's about plugging it into all 3 equations of the entire system to see if it's true. Now, you guys do have calculators, so use them. I'm just going to use my mind right here. I say use a calculator, but if I plug in a 1 right here, what's 3 times 1? It's 3. Plus the y value of 3. So you got 3 plus 3, that's 6, right? Negative 2 right there, that's negative 2 times negative 2 is positive 4. 6 plus 4, it really does give you 10. Again, I'm doing this in my mind. I'm explaining it out loud, but it's a good idea to use a calculator and write down these numbers on paper, right? Let's go for the next one right here. 6 times 1 is 6. I would write down 6. 3 right there, 2 times 3 is 6. 6 take away 6, you know that that's 0. And then plug in the negative 2 for the z. 0 plus negative 2, it really does give you negative 2. So it works for the first one, works for the second one. Third one, plug it in right here. You got 1 plus 4 times 3 is 12. 1 plus 12 is 13. And you have 13 plus 3 times negative 2, that's negative 6. 13 plus negative 6 really does give you 7. So I have not double checked it, but triple checked because it works for all 3. Okay? And that's what you're supposed to do if you want to guarantee yourself the right answer. Okay? So whenever you do solve a 3x3 system and you get an answer, and you're wondering, did I do this right? Did I do this wrong? Just go back, plug it into the x, y, and z on all 3 equations, and you should get true statements on all 3. So again, the whole purpose of this explanation here, or this video I'm making, is for you to get comfortable with the steps. Okay? Once you get comfortable using these steps, you're going to be able to use those steps down here, read through the steps, you'll be able to follow them. And once you follow the steps a couple of times, it'll be like riding a bike. You'll be able to do it without looking at the steps, right? Now, let me tell you on the practice, this is our homework, by the way, and we have the rest of the class to work on this. And let me tell you, 2 out of these 4 will be ordered triples, kind of like we got an ordered triple up here, okay? So 2 out of the 4 are going to be regular answers. X equals this, Y equals that, Z equals that. But 2 of them are going to be special cases. Now, what do I mean by that? Let's say you were working on your new equation number 1, and let's say you wanted to cancel out z's, but let's say that when you were trying to cancel out z's, after modifying them, let's say the x is canceled, the y's cancel, and the z's cancel, but the numbers don't, and you get 0 equals 6. What could you do right there? No solution. You should be happy when that happens, especially on step 1. Because if you have 0 equals 6, you could just say no solution and you're done, and you don't have to deal with the rest of this craziness, right? But maybe you do get a new equation 1, maybe you do get a new equation 2, who knows, maybe when you create your new 2x2 system, maybe right here, when you try to cancel something, like over here we canceled out the y's, maybe when you're trying to cancel out y's, maybe the x's also cancel and even the numbers cancel. So you'd end up with 0 equals 0. Then what would you say? Infinitely many solutions. So just like we had last week, sometimes no solutions, sometimes infinitely many solutions, same situation here. If you end up with everything canceling, the x's, the y's, the z's, and the numbers, you get 0 equals 0, that's infinitely many solutions. If you ended up trying to cancel something out, but then you see the letters cancel, but the numbers don't, let's say you got 0 equals 99, then you could stop and say no solution, right? But again, the process, final reiteration of these instructions, use 2 of the 3. I picked these 2 yellow ones. I didn't have to pick the first 2, I just decided to. I could have picked the first and the third, I could have picked the second and the third, but I picked the first 2, and I decided to cancel out a variable. That variable was the letter Z, producing new equation number 1, and that is step 1. This was step 1. Step 2, go back, use the one you haven't used. That's this one, I rewrote it. And then use another one, modify it, get the same variable to cancel. So if you cancel out z's up here, you need to cancel out z's down here. If you happen to cancel a different letter, it's not going to help you at all, because when you create your new 2x2 system, you need the same variables. You can't have x's and y's up here and x's and z's down here. That's not going to help you. So again, whatever variable you canceled on step 1, you need that same variable to cancel on step 2. Step 3 is to take your new equation number 1, your new equation number 2 that I recommend everybody box in, and then just create your new 2x2 system. And then you solve that the way we did last week, linear combination / elimination method. Get your 2 answers, plug them back into any original problem. That's step 4, substitute it back into any original problem, and get your 3rd answer, write it as an ordered triple, and then double check your answer. So that's it for this video. That's it for this introduction. I do want you to practice right now with number 1. And you might want to write this over in your notebook, or you want to write really tiny, but very important, guys, that you be crystal clear with your work. Draw arrows, that way you know how you got from here to here. Use the parentheses, use the numbers, draw arrows so you can know how we got to these equations. Very important that you're very detailed with your work.